Hello, I am Juan-Juan, your Six Sigma instructor, and today we will be talking about one of the most complex topics in Six Sigma, the design of experiments, or simply known as the DOE. In addition, we will be using Minitab for developing a Taguchi design.
Juan-Juan, it's been a while since you posted a long video like this.
See, Mimi, actually, I was conducting an experiment myself.
What was your experiment about?
Well, I was posting short videos on YouTube and TikTok.
What were the responses of your experiment?
Oh, nice term, Mimi. Responses is another word for the results or outputs of your experiment. Well, I found out that no matter how hard you try, you cannot defeat the YouTube and TikTok algorithms. Anyhow, let's talk about DOEs. Welcome back. DOE is one of the most extensive and complex topics in Six Sigma, and it will be impossible to include everything in one video. So, for this video, we will be focusing on some basic concepts and how to develop a Taguchi design in Minitab.
Juan-Juan, could you start this video by explaining what DOE is?
Absolutely! Design of experiments is a methodology which includes steps for planning, conducting, analyzing, and interpreting controlled tests or experiments to evaluate how much the factors or inputs of your process have effect or control over the outputs of your process. The best way to understand the DOE methodology is using an example, and we will be using Minitab to do so. Let's say that you work in an injection molding company like me, and you want to evaluate how much the weight of your final product and a couple of critical dimensions can be influenced by modifying the temperature and injection pressure of your process. So, for the planning process, we have determined that the factors or variables of our process are going to be the temperature and pressure, and the output of the experiment or responses are going to be the weight of the part and critical dimensions. Just remember that a higher number of variables requires a higher number of experiments to be performed, also known as treatments, and in consequence, a higher price of your DOE. As a Six Sigma specialist, you must always keep an eye on the money, since one of the goals of Six Sigma is to increase the profits of your organization and reduce cost and waste. So, keep this in mind when designing experiments. The next consideration for our plan is the levels. For this example, we're going to select two levels for our temperature, 410 and 480 degrees Fahrenheit, and for the pressure, 500 and 1500 psi. By the way, the real parameters are different, but I had to change them due to company proprietary reasons, but the results in Minitab are the same. Going back to the design, at this point, we have established an arrangement of two factors and two levels, which is the smallest Taguchi arrangement that we can design. But for your particular needs, you may need a different number of levels. Just keep an eye on the cost.
Juan-Juan, I think from this point forward, you should show how to develop the DOE in Minitab.
You are right, Mimi. Let's go to Minitab. For this example, we are going to use Minitab version 22. If you are using a different version, your screen may look a little different, but the commands are exactly the same. To create our Taguchi arrangement, go to Stat, DOE, Taguchi, Create Taguchi Design, and select two-level design. Number of factors, 2. Click Designs and pick L4 2x2. Click OK. On the factors screen, type under name, temp, and pressure, and under level values, type 410 and 480 and 500 and 1500 respectively. Don't forget to add a space between each value. Click OK and then OK again. And voila! Minitab creates the table design, also known as the arrangement. In column C3, C4, and C5, change the labels to weight, dimension 12 and dimension 37 respectively, which will be the outputs of the process or effects. This table works like Excel, except for the extra line for the labels, which, by the way, has no name. The little arrow in the corner of the table is only to indicate the entry direction. In other words, how Minitab reads the data, in this case from top to bottom. The table is ready to record the data of our experiments.
Juan-Juan, after the arrangement is ready, what is the next step?
Oh, Mimi, the next step is to actually conduct experiments, in this case in an injection molding press, and record the data in a table. After doing that, the table is going to look like this. And as you can see, we got the results of our experiments for the weight of the parts and the dimensions.
And then what is the next step?
After that, we need to analyze the data and the results using Minitab tools. But before we do that, let's take a break. To start the analysis of the data, we will create a main effects plot for means, or average, for our data. To do that, go to Stat, DOE, Taguchi, Analyze, Taguchi Design. On the response, select C3 Weight. Click OK, and voila! Minitab creates this chart, which is the main effect plot for means. What this chart is telling us is that the changes of pressure in our process has a bigger effect than the changes in temperature, since the line for the pressure has a larger slope than the line for temperature. In other words, a line that is closer to vertical indicates a larger effect, while a line that is closer to flat indicates less or smaller effect. Also, as you can see in the chart, when the pressure is changed from 500 to 1500 psi, the average weight of the parts, or mean, changes from 38.5 to 38.75 grams. But when the temperature changes from 410 to 480 degrees, the average weight changes only from 38.65 to 38.60, confirming that the pressure has more effect in the weight of the parts than the temperature. To analyze the effects on dimensions, we repeat the steps shown before. Go to Stat, DOE, Taguchi, Analyze, Taguchi Design. But this time, in the response, select dimension 12. Click OK, and voila! Minitab creates another main effect plot for means. As you can see in the chart, the temperature has no effect on the dimension, since we got a flat line. On the other hand, changes in pressure from 500 to 1500 psi produce a change on the average of the dimensions from 15.25 to 15.75 millimeters. If we repeat the steps for dimension 37, the chart looks a little bit different. In this case, both temperature and pressure have some influence on the dimension. But as you can see, the line for pressure is more vertical than the line for temperature. So we can conclude that again, the pressure has a bigger influence on the results or outputs of our experiment. There are several other charts in Minitab that we can use for the analysis of data. So let's do another one called the interaction plot. To create this chart, go to Stat, ANOVA, Interaction Plot. In responses, select weight, and in factors, select temperature and pressure. Click Display Full Interaction Plot Matrix. Click OK, and voila! We get this chart. This chart is similar to the main effects plots previously analyzed, with the difference that we can see all of the effects at once and you can see 3 sets of data at the same time. Let's start with the bottom left quadrant. Here, the blue line represents a trial or experiment where we did set up the pressure at 500 psi. And as you can see, the weight did not change when the temperature was increased from 410 to 480 degrees. So we are seeing at the same time the effects of pressure, weight, and temperature. The red line is for the experiment where we did set up the pressure at 1500 psi, and we can see that the average weight of the pieces produced decreased as we increase the temperature. On the upper right quadrant, the blue line represents the experiment where we did set up the temperature at 410 degrees, and as you can see, the average weight of the parts increased as we increase the pressure. On the same way, the red line represents the experiment where we did set up the temperature at 480, and we can see that the weight of the samples also increases as we increase the pressure, but not as much as the blue line. This analysis will allow us to make decisions about our process because we have enough information to modify the weight and dimensions of our parts by modifying the temperature and pressure depending on what the requirements of the customer or the blueprint are. There are many other charts that we can create in Minitab to analyze the data, such as box plots or capability 6-packs that I will cover in other videos. For now, this concludes this DOE basic video. Now, let's go to the final thoughts. As I mentioned before, DOE is a huge Six Sigma topic, and in this video, we just scratched the surface. However, the Taguchi arrangement is one of the most useful techniques for a quick and simple experiment, so use this tool wisely.
Juan-Juan, are you going to continue making long Six Sigma videos like this one?
Oh, sí, Mimi.
What about the shorts in YouTube and TikTok?
Well, Mimi, the data shows that the videos with young and beautiful people or with special talent are the most successful.
So how are you competing against that, Juan-Juan?
Well, I am neither young nor beautiful, but I can show one of my special talents.
What talent is that?
I can dance! Hit it, Mimi!
Ay, ay, ay.